All right, well, I think I'm recording now. We have in this problem number one, three equations and three unknowns. We refer to this as a system of linear equations. It's in three-dimensional space, and we are looking to see if we can find a point of intersection where these three lines intersect each other. The method that we will use is referred to as method of elimination. We are going to pick one of the variables to eliminate. There is no wrong choice. We could eliminate X, Y, or Z, but oftentimes there is a simpler choice, one that will lead to a correct answer, maybe with the least amount of mistakes, with the easiest amount of work. I look for coefficients of 1 or -1. I see that here with X, but with the Z's I have 1s and 2 equations. I know that I will easily be able to get those coefficients to be equal and opposite any value that I want. So I'm going to choose to eliminate the variable Z. I'm going to label my equations, number them 1, 2, and 3, just to try to help with my organization. I'm going to begin by simply adding equations 2 and equations 3 together because that will eliminate Z. So I'm going to take equation 2 plus my equation 3. These are just my little scratch marks, notes to myself, reminding me what I'm doing as the problem goes on. These problems are not difficult, but they are long. And because they are long, you have to be organized as you solve them. You can make silly mistakes or work with the wrong equation. And anytime there's an error, why that error follows in everything after that you do. So let's write equation 2 down. One of the mistakes that I often make, and I even remember doing it when I was younger, is I'll begin to copy the equations down, and as I look back up, I won't return to the same equation. My eyes will go above or below. So the equation I write down will be a combination of two or more of the equations above. So I've gotten in the habit to when I get it written, or you'll hear me just out of habit as well in class, hey, did I copy that down right? Because I want to do the same problem that everybody else is doing and not to be doing the only one in the room that's doing my own problem. All right, so we want to now write equation 3 with the same remarks. Now you'll notice that I'm putting a 1 in front of the coefficient, and I didn't there. It often helps students for, again, silly type of errors when you're combining these variables. At the beginning of the problem, I should have noticed or remarked that the x's are in one column, the y's are in another column, the z's are in a column, and the constants are on one side of the equation. In this case, the right side of the equation. So it was set up, if it wasn't set up like that, I would manipulate through addition and subtraction. I would move those terms to the correct side and position them in a correct way. When I add these expressions together, Z will be eliminated. That was what I wanted to happen. Now, here's what I do again. I know that one of my weaknesses is arithmetic, and I know that being a math teacher, that sounds strange. I look at this and I see all of these values are even numbers, and then if I divide everybody by 2, it doesn't affect my solution set, my final answer, but it will make these values a number smaller and easier arithmetic, or at least for me. So I'm going to number this equation 4. I'm going to shrink this up a little bit, and on the side now we have one equation here and two variables. If I have two variables, I need two equations. So I want to come back to my original system and eliminate Z again. Now since I've used equation 2 and 3, in the second elimination here, I have to use the equation 1 because I haven't used it yet. Now I can use equation 1 with equation 2 or equation 1 with equation 3. That doesn't matter. So to eliminate z, I have a negative 3 here. I would love to see a positive 3z, and I'm going to take equation 2 and multiply it by positive 3. So here's my plan of attack. I'm going to take equation 1 as is. I'm going to add 3 times equation 2. So equation 1, copy it down correctly. And 3 times equation 2 Now when I add these together, the z's are eliminated. So I have accomplished my goal. Let's label this equation equation number 5. Now, to give us some room, I'm going to copy these equations. Let's group it together. Let's copy it. Let's move it to the other side, and then I'll erase what I don't want. If you write too close together, when it goes to select it, it selects the whole thing. Alright. So here's one of the equations. Let's go over and grab the other one. It may not let me. Boy, it's picking the whole thing. Group it. Ungroup it. Nope, it's not. Well, I guess we'll do a lot of erasing then. It's usually a little bit better about selecting what you want. Maybe it's because I shrunk it up and then expanded it. I'm sure that's probably it. Alright, so now it should like that, yeah. And we have 2 equations and 2 unknowns, and we want to eliminate either the x variable or the y variable. Since I have a coefficient of 1 here, I'm going to choose to eliminate the y variable. So if I eliminate y, I'm going to take equation 5 and add to it negative 13 times equation 4. That'll get me a negative 13 and a positive 13. So I copy equation 5 as is. Negative 13, everybody gets multiplied by a negative 13. Negative times negative is positive. I get the equal and opposite coefficients in y that I wanted, and negative 13 times a negative 12, it's going to be bigger than 144. Let's see what it is. Negative 13 times 12, negative 156. Alright. So let's add these 2 equations together. This is eliminated, and we have negative 110. Both of these are even numbers, but they're both. It's not divisible by 11. Oh, of course it is. 11 times 10. All right, so if I divide both sides by 11, divide both sides by a positive 2, and that should work for that. Now, we want to, we have the variable x now. We return to the immediate system that was right above it, the pair of equations, and we substitute to solve for y. And we can use either equation 5 or equation 4. The numbers in equation 4 are so much smaller and easier to who wants to deal with dividing by 13. And let's use equation 4. So let's shrink this up a little bit. And I can do it up here. I've got equation 4, which is negative 3 times x, but I'm going to replace that x with negative 5. Then plus y is equal to 12. Well, a negative times a negative is positive, and 15 minus 3 is 12. Y has to be a negative 3. Now, in order to find our, because remember, we can't stop after we just found x or after we just, we need to find x, y, and z, a ordered triple. And we don't, these equations did not have the variable z, so we have to come back to our original. Let's copy it and move it over here. Kind of place it down here out of my, where I can see it. And we're solving for z. So I'm just going to go ahead and I'm going to pick equation 3 here. So if I take the opposite of x, the opposite of negative 5 is 5. And minus 3 times a negative 3 minus z is equal to 12. So that here I have 5 plus 9, I have 14. So we can see that z is 2. 14 minus 2 is 12. All right. When we're presenting our solution, the ordered triple by convention is x, comma, y, comma, z. But as long as you have shown your work and stuff, there are many of you that didn't write it as the final answer. You should get in this habit. There may be someday a professor or an instructor or teacher that wants you to write it like this. They insist that you, or a multiple choice test where the different choices jumble those values around, and anyway, you need to know that. So I get negative 5 comma negative 3 comma positive 2. Let's take a look at the second problem. It's different than the first problem because on the first problem, all of the exponents on the variables were 1. And so we knew that the graphs were lines. We refer to these as linear equations. In number 2, we have a linear equation in equation 2, but in equation 1, we have a quadratic. We have a term with an exponent of 2. This is a second degree equation. We usually refer to it as a quadratic. Now, this elimination method is not going to work because we'll never be able to eliminate that quadratic term without, if you introduce multiplying by x by both sides, then you have an x times y. Well, that's not going to eliminate. So substitution is going to be your method of choice in this type of a problem. Now, before we just jump in and start doing the algebra, think a little bit of what you're expecting. We know from previous experience, like if you just had y equals x squared, that's a parabola. Even the plus 6x and plus 8 isn't going to change that. Whether the leading coefficient here is positive or negative determines whether it opens up or down. This other equation is going to be a line. You're given it in slope-intercept form, mx plus b form. The slope is 2, the y-intercept is negative 8. But see, I'm not going to use a graphing method to solve it because I don't yet know if the points of intersection are integer values. Is it going to be easy for me to read points off of a graph? And I don't have any graph paper, and I really don't want to try to sketch it by hand and not have it drawn to scale and then try to read off, points on a graph. So substitution is going to be our method of choice, but that doesn't mean that we can't make a sketch as kind of a plan of attack and knowing what to expect in our answer. So if this line, it may not cross the parabola at all, or it may intersect it at one point, but I suspect it might intersect it in 2 points. That's the problems that we had in our homework. And I'm looking to see if you've studied and done that homework, and so I'm not looking to find one exceptional case that we've never looked at to try to trick you and stuff. I'm trying to make it, straightforward. Did you understand the things that you did? Did you understand the material and the type of problems that we did in class and the type of problems that you did in homework? All right, so remember that each one of these points is an ordered pair. So for this point, I'm going to have an x and a y. For this point, I'm going to have an x and a y. So let's see if we can find those. All right. Now that was just for discussion. I'm going to erase this just in case I need that room. Now with substitution, we want one variable, it's solved for in terms of the other, and then substitute into the other equation. This is set up perfect to substitute. I'm going to substitute equation 2 into equation 1. I'm going to, everywhere I see a y, I know by this equation 2 that y is equivalent to 2x minus 8. So everywhere I see a y, I can replace it. So instead of, if I write down equation 1, instead of writing y equals x squared plus 6x plus 8, since y is equal to 2x minus 8, this and this are equal. They look different, but they're the same value. So that equality has to be true if these are the same. Now, I have a new equation. It's in one variable. It has a degree of 2. This is a quadratic equation. Of all the types of equation that you've studied in high school, in pre-algebra they might have been lines. Quadratic equations you have studied a lot. You have seen it in Algebra 1, you have seen it in Algebra 2, you have seen it in geometry. So by now, hopefully you realize that one method of solving this is the king of methods is the quadratic formula. So we want to get this in what they refer to as standard form. I suppose somebody might call it a general form, but we want a 0 on one side of the equation and everything else on the other. So I'm going to put my 0 on the left, and I'm going to move these terms to the right hand side. The x squared stays where it is, and there are no other x squared terms. These linear terms, they're like terms. I'm going to get them on the same side of the equation and combine them. If I take away 2x on the left, I won't have anything. I'll have the 0 I want. So to balance the equation, I have to take 2x away from these 6x's, and that will give me 4x. Here, I have constants. I want them on the same side of the equation. So to get a 0 on the left-hand side, I'm going to add 8. To balance the equation, I'm going to add 8 on the right-hand side. And 8 plus 8 is 16. All right, so now I'm looking to solve this by either factoring or by the quadratic formula. I'm going to double check this real quick. I'm going to pause the video for a second too and take a break. Alright, so I'm back. Well, let's double check. I don't think I have made any silly errors, and unfortunately this was one of your quiz problems. There were 4 different versions of the quiz, and I wanted to have unique solutions. I wanted to have integer points on each one. I think I'm going to have to apologize for this problem because this appears to be a situation where I have a parabola and I have a line that is not intersecting that parabola. I have a no solution case. So let's go back and take a look at this, and we're going to do a quiz retake. So I'll definitely in some way make sure that people are not penalized for a problem because we didn't see one of these in the homework. Like I mentioned before, I want these to be like a homework. So I used a computer program that generated these problems, and I thought that I set the parameters for a solution, and that I must have either used the program incorrectly or it gave us a case where it was a no solution case. So next time I'll write these out and I'll create them by hand to make sure. I just guess that I trusted the program a little bit too much. Alright, so like we said, we have a quadratic equation. And it opens upward. We have a line that might intersect that parabola in 2 places. That was the intention. Now it is possible to have a line that intersects the parabola in 1 place. And what might have happened here, unless I can catch a silly mistake, is that the line is not intersecting the parabola at all. So let's see what's going on here. It is set up perfect for substitution. Everything that we have said as far as the theory of solving this is correct. So our 2x minus 8 equals this. That's correct. Let's subtract 2x from each sides, and 6 minus 2 is a 4x, and if I add 8. So although your next quiz will talk about the discriminant, and remember the discriminant told us the nature of the solution. So let's use that right now for just a second. Let's identify A, B, and C, and let's see if we have to use the quadratic formula or if we can say a no solution case. Because remember, the quadratic formula is the opposite of b plus or minus the square root of b squared minus 4ac, all divided by 2a. Alright, so I don't want to solve it first. I want to see if it's a no solution, so I want to find the value of the discriminant. I want to find this number, and if that number is negative, then I know I have a no solution case, and that was not my intent. I suppose technically it's fair game, but like I say, in my viewpoint, it's not fair game because I really didn't give you those type of problems for homework, and we discussed it briefly in class, but we didn't have concrete examples demonstrating this. Now, sometimes in college, if they mention it like that, hey, you're responsible to go figure it out. So, but I've always kind of thought that sometimes that was unfair. And you can see here that 16 minus a 64 is a negative number. Okay, so this is a no solution case. There may have been a couple of people that wrote no solution on that quiz. I'll go back and check, and I counted it wrong because, of course, from that program and stuff, while I didn't actually work it out, I believed them in their solution. Or I guess in typing the quiz, I could have, maybe that's more likely, that I had a typing error from the problem that it spit out. But anyway, I apologize, and I will make it up to you. So let's still view this video as informative and learning, but look at one of the other versions of the quiz. I know I just did one of the versions and it had a solution. So version 1 I know is a good one to look at and study for the retake. And now that I've done this mistake, well, I will probably just allow the retake. We'll try to do it to do it in class, but I mean outside of class, before or after school. But since it was my fault, we can do it in class if necessary. All right. Well, sorry about that, and I'll talk to you later.